Hi everyone, my name's Pathmanathan and I'm a science education consultant. Thank you to the Finding Ada conference for inviting me here today to give this talk, and I'll be talking a little bit about the different types of science engagement that I do, from developing hands-on activities to the other forms of science engagement that you can do with young people, with community groups, after school science clubs, without having to do those big explosive science shows. So I've been working in this field for about 20 years now, and I've worked with all kinds of different clients. So basically today's talk is all about the things that I do and how to go about doing it yourself. So I think as people come into the field of science communication, there seems to be this feeling that you need to be able to do these big science shows or at huge events, science communication events or public engagement events. And there are amazing people out there that can teach you a little bit more about how to do that and how to go about running these science shows. Unfortunately, I'm not one of them. I work with much smaller groups and on a sustained engagement basis. So I work with them regularly. So that might be after school science clubs, it might be community groups or community festivals that happen regularly, like every year or so, so that I get to see the same people, get to talk to them, and you can build up a sense of trust. And this is what's really important to me, because the more trust you build with these people, young people, their families and communities, they get a chance to feel more comfortable about asking you more questions, discussing all their ideas and wanting to have a genuine engagement and dialogue with you. And that's been really vital during this pandemic, because people who have various queries, they might ask me these things, these questions. And even if I don't know the answer, I'll know someone who does, and I can put them in touch with them. So it's been really good in that way, and that's the kind of thing that I love to do.
Quick disclaimer, I'll be talking about various bodily functions, so I really hope no one is watching this while eating.
Even though I work across different ages, from nursery to postdoc, different backgrounds and different disciplines, I tend to gravitate more towards health engagement with young people and their families. As a researcher myself in neuroscience, I was always looking for creative ways to talk about my research and doing hands-on experiments around my research. That's what I really love about my job now, is to work with researchers to come up with creative hands-on ways to engage audiences with their work. Much of what I do is with small groups, as I've mentioned before, and it's with small groups of young people. So whenever I'm developing a resource, it's for how I would present it to those young people. Now, when I develop resources and write activities for other clients, I'm still working on that assumption that someone else is going to be doing my role delivering to young people. And so, because everyone could be everywhere and people have all different needs and we want things to be as inclusive as possible, I try to make all the activities contain elements and ingredients and equipment that anyone can find. So that has to be simple household materials, things that children can find outside, things that resource developers could be easily able to source. Which is why I wrote this book, Utterly Jarvelous, which is published by Bloomsbury Education and is 50 primary science activities which you can do in a jar. And there's actually more than 50 activities if you look very closely. And this was because I was increasingly using a lot of single-use plastics in my workshops because they were so light to carry. Basically, that was the only reason. And I started having this overwhelming sense of guilt that actually this was all going to end up in landfill. However much I tried to reuse, repurpose, recycle, I didn't know where they were actually going to end up. So I thought, how can we adapt activities? How can we develop new activities that young people can do with things that they can find in the home quite easily, but were recyclable, compostable, edible even. And that's how this book came about. Now, I'm going to be describing a few of the activities from the book, I won't go into too much of the science explanation behind those because that's in the book, and also people can just contact me and ask me more questions. So let's have a look at some of those activities.
So one of the activities in the book is all about growing basil in a jar. And once you grow basil, you can start looking at the flowers and then the seeds. So children can end up with a whole basil plant that lasts for quite some time, and they can eat all the leaves, they can look at the flowers, and they can also try and spot the little seed pods. So there are some little drying seed pods right there. And then once they've got these seed pods, they can now start to harvest their own seeds. So here's a set of seed pods that have fully dried, and you can see the tiny little basil seeds in each pod. So it's simply a matter of just popping them out and harvesting all those seeds. These basil seeds that you've just harvested can now be added to a glass of water or a jar of water, since we're talking about utterly jarveless, and then watch what happens to the seeds. The seeds start to grow this jelly-like coating known as mucilage, and children love watching this happen right before their eyes. So we can look at the comparison between the seeds that were just harvested to ones in water, and this works brilliantly with reception groups. Now a big shout out to 23rd Bethnal Green Brownies, yay, for coming up with a fun adaptation of one of my activities, namely making lots of flowers. So this is all about capillary action and how water travels up through plant fibres, or in this case card and paper fibres. So taking each flower, we just fold in all the petals, and we need to do that for all of the flowers. And the tighter you make it, the better, because it's more impressive. Then we need a jar lid of water, and then take all the flowers and drop them in one by one. And then we can watch each flower bloom slowly, and some of them are faster. And this is something that you can do with any age group. It works with young people, old people, everyone loves this. This next activity uses a jar, surprise, surprise, and is all about looking at how air moves. And for this we need a candle as well, a little nightlight candle, and this needs to be lit. So sometimes this activity is best done as a demonstration, but young people can be called upon to do the next part once the candle is lit. So this candle needs to go right behind the jar, and we'll place the jar in front, and then you're going to blow on the jar and make the candle go out like that. This activity is all about floating a piece of potato called flotato based on the different densities of the potato, water and salt solution. You could even try copper plating your paper clips using copper coins, and this is a reaction that happens within an hour. You can watch the paper clip right before your eyes gradually get coated in copper, and this is assuming you have enough copper coins lying around. Activities can still be engaging without needing lots of equipment, or they needn't even be hands-on in the sense of mixing things like liquids and chemicals together. With the Physiological Society, I worked on a board game around the topic of sleep, which was easily downloaded, printed off, and could be played with people all over the world. And with the Royal College of Pathologists, I worked on a genetics game, which was very similar to the popular Twisty game, which I'm sure you can all guess which one I mean. My workshops and science clubs are very open and playful. They give young people and their families a chance to play with science and then chat with myself and other colleagues. But it's important to look into what your audience needs and why you're doing this in the first place. I mean, are you raising awareness of something? Are you wanting feedback on your research or project? Or are you teaching something? Most of my school workshops fall under teaching or informal learning, but working in health engagement can be more about raising awareness. I've always been interested in the power of humour and storytelling in helping with learning. But it's not just the emotion of humour, because disgust and gross stuff also really help in learning. Events such as the BBC World War I at Home roadshow, working alongside pathologists, we had a variety of stalls discussing the innovations in medicine around haematology, i.e. blood, and microbiology, i.e. bugs, so we called it Blood and Bugs. There was a lot of history and a lot of fake blood, and we honestly only had a few people faint. The hands-on element was very simple, just looking at the consistencies of clotted blood, which had some sodium alginate or warmed up corn flour mixed in with some red food-coloured water, and then comparing this to what our normal runny blood inside our body looks like, and then discussing why we need sodium citrate being added to blood bags, which stops blood from clotting.
History also played a huge part in a Fun Palace's Lucky Dip community activity called The History of the Balanced Diet, which was all about different elements of our diet and how we discovered that they were so good for us. And it was funded by the British Society for the History of Science. And this was another activity that allowed community members to just do a bit of self-directed learning, and if they wanted to know more, they could take part in some hands-on activities too. We've also looked at the colours of urine. In other words, does it mean something health-wise if you see something different in your pee? These were of course tubes of water coloured with food colouring, but offered young people and general public a chance to learn about how the things we eat, such as beetroot, can make our urine change colour. But a pink wee could also mean the sign of blood, so you'd need to get it checked out. Now, poo was a big part of the Eat, Poo, Sleep activities funded by the Physiological Society, some of which were huge public events. We also talked about digestion in general and discussed and tasted insects as a future food source. Tasting activities like this always work well, although I'm not sure whether we can do many of these at events now. Children learning to make butter with their families as part of a storytelling and science project called Experimenting with Storytelling, which was funded by the Biochemical Society, also enable them to learn the biochemistry of butter making. Having parents and carers available to work with their children meant that they saw firsthand what excited their children and what they can do to encourage their children's learning further. There's always parents reporting back of doing more at home, and children's feedback is always, "It's so much fun doing this with Dad, Mum and Grandpa." Plastic is Not Fantastic, funded by the Winston Churchill Memorial Trust, was a series of events in schools and at public community events looking at ways to reduce, reuse, recycle and repurpose plastics. We even took the molecular gastronomy technique of spherification, allowing people to recreate and taste the same edible uho or nopla water bottles, but on a much smaller scale. Sometimes to mix things up a little by taking in equipment or ingredients that aren't commonly found in the home can be quite awe-inspiring too. Hands-on activities such as these allow people to feel comfortable asking questions and telling you what they know too. People love doing things, whatever their age, so everything I do is as hands-on as possible, and I totally believe that any subject can be turned into a hands-on activity. For example, rather than teaching why indicator colour changes are happening, or in this case, pouring some tonic water into a glass and show why something glows, so the quinine in tonic water will glow under a UV blacklight. So we have some plain water on the right and we have tonic water on the left. And we can see that under a black light that the water just looks purple and the tonic water glows. So why not use these simple reactions to demonstrate or simulate something else around health and disease that would be difficult to do otherwise and pretty dull in digital or paper format? We can take the tonic water and mix it with the tap water and watch the whole thing as a mixture fluoresce, so the whole thing glows. And I've used this mixing and glowing to demonstrate how malaria spreads through a population, using pipettes as pretend mosquitoes. And I also use butterfly pea flower tea extract or red cabbage indicator to demonstrate herd immunity.
Right, so I'm going to go back to some icky, gross stuff and talk about poo again. So if you feel slightly squeamish or anything, you might want to fast forward this bit. So basically, I've done some work with the Royal College of Pathologists where we were looking at ways to raise awareness of bowel cancer or colorectal cancer. And it's because in the post, when people reach the age of 60, they get a small card in the post called the fecal occult blood test. So it's FOB test. And this test requires you to open up a flap of the card and place a sample of your stools onto the card, fold it up, put all your details on the thing. You might want to write your details before you put your little poo samples on there, and post it off to the pathologists. Now the pathologists analyse this and then they can see whether you might need to have some more further tests done to see whether there might be a sign. So the reason the card works is that you can see any presence of blood in there. So if there's any blood in the sample of stools, it might be a sign of something wrong with your bowel system, but it could also be an early warning of cancer. So this is why pathologists wanted to raise awareness of why we should be doing these tests as soon as it comes in the post. What we wanted to do was find a way to do this test in a community setting without actually using human poo samples. I mean, who would do that? So I started talking to scientists and pathologists that might have done this activity before in a similar setting. And some of them said that they used crab meat, which I wasn't too keen on using. And others said that they used chocolate cake. And I was like, okay, chocolate cake, we can deal with that. But then finding out how they actually did the test was to mush up bits of chocolate cake and give that as the poo sample to young people, families, community members, to then spread on the card, on the fecal occult blood card. And they did that, and then they would fold up the card and give it back to the person who was delivering the activity. So it's all great so far. The only thing was that afterwards they would be given a laminated card with the results on that, so a little photo of the results. Now I didn't find that as engaging as it would be if you could actually see the reaction happening on the card. So what the pathologist would be doing, so when they receive the card in the lab, what is it that they're adding, the reagent, and what is the reaction that you see? Whereas this was just giving them the results as a photo, and they'd have to analyse who had a positive test and who had a negative test. So I wasn't too keen on that idea either. Making a negative test, that was fine because you could use a mushed up chocolate cake. So how was this test working, and how could we mimic that so that the samples, the pretend poo samples that we make, could that actually give a positive result using the same reagents that the pathologists are using in the lab? So that was one of the things that I was tasked with doing. After a lot of digging and asking a lot of people a lot of questions, I found out that the test card, is actually impregnated with a resin. Now this resin turns blue when a reagent is added, and this reagent in the lab, which is what the pathologists were doing, is hydrogen peroxide. Now the blue colour appears quicker when it's catalysed by heme that's in the haemoglobin in the blood. So if there's blood in your stools, and then the reagent, the hydrogen peroxide, is added, it turns blue quicker than it normally would on the card. So using this knowledge, I wondered whether horseradish would work, because horseradish has got peroxidase, so this would also catalyse the reaction quicker, make the reaction happen quicker. Or like something much easier, because horseradish isn't everywhere, Potatoes, because potatoes have catalase in it. So basically we made a positive poo sample, so one that has got some heme in it, by making the poo out of cocoa powder, porridge and some potatoes, and that did give a positive result. This is why I really love this part of my job, because it's simulating exactly what's happening in the lab, talking to lots of different experts, finding an easy way to do this activity in a place where you won't have access to all of these different pieces of equipment, or you can't use real human samples. So that's what I really love about doing this, and I've made a mess in a lot of different offices trying to set this up, testing them, asking people for their feedback. So it does take a lot of work, but it's so rewarding at the end, because especially in this activity, we were able to raise awareness of cancer screening, but also talk about false positives. So in this activity, if you have a diet that has these catalyzing elements in there, you might show up as having a positive test. There's now actually a new test which is much more accurate, that is based on immunochemistry. And so to be able to discuss this new test that is now being used while the other one is being phased out, gives us a chance to talk to the general public about how tests are constantly evolving and why they're evolving, because we need things to be, as we learn more, we need things to be more accurate and we can change things. And the great thing about using just cocoa powder and porridge oats is that you can mix up a few extra ingredients and then turn them into cookies. Win-win! From a health and safety point of view, there's very little you need to worry about if everything you use is completely safe, even edible. So whenever I'm at an event and a little 3-year-old sticks their hand onto the table and tries to take something to put in their mouth, if everything's safe, I have very little to worry about.
As I've worked mainly with family audiences for such a long time, I've grown to understand how to tailor my messages and activities for them. But as a rule of thumb, I test out all my activities with 7 to 8-year-olds, even complex science. As if it works with a 7-year-old, it'll work with anyone. Everyone should have the opportunity to engage with science, whatever their age, background, ability, etc. And I really believe that hands-on activities can engage any audience.
So that's it. Thank you all for listening, and now I think it's time for some questions.
Si, welcome to the Finding Ada conference.
Yay, thank you for having me.
It was a really great talk. Thank you so much for recording that for us. We just have a few questions for you. So I'll dive straight in. What do you think makes a good demo, and how do you decide what's going to be a demo and what isn't suitable?
So I think what makes a really good demo is something that's really engaging and hooks as many people as possible. So I like to do things, like I said in my talk, I like to do things that are edible, things that are gory, things that are really funny, to try and appeal to as many people as possible. I think with some, there are, I don't know, I haven't really found anything that's too difficult to do as a demo, because that's part of, I think that's part of my job. I really like to work out, how can this work? What can we do? Like anyone that was able to sit through the whole poo description, they'll know that I sat there trying to work out, a bit like a detective, trying to work out why it works, how it works, how can I manipulate what's happening in there, what are the materials that are being used in the lab, how can I find things that are more accessible, that anyone can find, anyone can use, and other people can do it, and then use that and to make the demo. So I like a challenge. So I think anyone that's quite interested and passionate about science wants to find a way to communicate it. and will do anything to do that. So I don't think I've come across anything so far. I'm willing to hear from people whether there's anything that they think wouldn't make a good demo, but there are plenty of topics out there, and I don't think I found one yet. So yeah, we'll see.
Excellent. So you mentioned you doing icky, gross stuff, gory stuff. Why do kids love that stuff so much? And do you ever get any pushback from the parents who are like, "Oh, this is too disgusting. I don't want my daughter doing this"?
Totally. I think I still don't know why children love it so much. I think it's because like just the words poo and bum and all of that, they just find that hilarious because they're not really supposed to talk about those kind of things in class. So they just love that. A lot of the children's books that are out there try to use that toilet humour to sell their books, really, because children love it so much. But I mean, we did have one time where I was actually setting up the new version of, so we got a new demo for the new version of the poo test, and we were setting it up with roasting tins, so that we could use something that was recyclable and reusable, to put all the bits and pieces into that. And I had porridge oats at the side. So we were setting up the activity, and it had a box of porridge oats and a carton of cocoa powder. And just before anyone could come in, a parent with a pushchair and two little kids either side came rushing in, and she saw what we had set up, and she said, "Oh my God, what are you baking here?" And I said, "Oh no, we're not baking anything. We're actually doing a thing about poo." And she looked utterly disgusted by this. But you could see her children were like, their eyes were popping out, and they wanted to come and take part in this, but she dragged them away. And I was like, oh, those kids really want to have a chance to like play with this and like learn more about poo and just have a giggle. But they later did come. They found some other friends and left their mother somewhere else and came with a whole bunch of other friends. And I think it was like an uncle or someone who was there with them. And they all wanted to find out more, and they had loads of fun. But you do sometimes get those parents that will just like drag their children off straight away. But the children always find a way to come back because they're like, oh, it's poo. So it's brilliant. And yeah, so I think getting hold of children that way, they just find it fascinating, like all this gory stuff. It's great. Yeah.
I think they just, poo is irresistible, right?
I know, exactly.
It's sort of
exactly.
Like the one. So you mentioned about kind of like using your sort of materials there. How much do you think about the environmental impact of the resources and materials that you use?
A lot. I mean, increasingly a lot more now. As you can see in the video clips that were there, some of those activities were really quite old, and I did used to carry a lot of mini, like the things that you could get from the pound store, because I thought I was thinking about accessibility and like where teachers could get as many things as possible for a cheap price, what kinds of materials they could use. So it would be like little plastic containers, reusable food containers, things that we like, margarine tubs, and all of that. But then the more I started thinking about this and where it was going, so you get children in my science clubs that would want to take things away. So I'd be like taking this all back from them and washing the containers out and then using it again the next week. Whereas when they started asking me, can I take these home with me? I was like, oh, okay, yeah, sure, you can take it because it's like my recycling that they're just taking away. But then they'd come back the next week and say, oh, my dad used it for something else and then just chucked it in the bin, or my mum threw it away because she didn't know it was my science experiment. So I started thinking, actually, this is my responsibility to make sure that this doesn't all end up in landfill. So part of that was to come up with, like, adapt a lot of the activities that I do, but then also come up with ways that that the materials were environmentally friendly, as in being like some of the things are edible, some of the things are compostable. A lot of it is recyclable, reusable in such a way that like if it's a glass jar, in my book, like Utterly Jarveless, if it's a glass jar, people are less likely to chuck it away. They will find another use for it. So yeah, I do think about it a lot more now. And I think as educators, I think it's something we do need to think about.
And what about the sort of like reusable materials? I mean, you're saying that's mostly sort of stuff that you can buy in the supermarket or wherever. So you do you sort of think about kind of what happens to all those oats afterwards, or is it okay to sort of like sacrifice a few oats for the sake of science?
Yeah, I mean, like I do. I mean, one of the things that I've spoken about is how, especially when we're talking about global science, that it is. I mean, a lot of things that are seen as food waste, effectively, like we are chucking it all away. But with the whole like poo things and the oats, the porridge oats thing, we have it on site. So I very rarely have done anything where I've had like a group of kids and just allowed them to take a whole pot, a packet of oats and just like do what they like with it. I would tend to be quite controlled about it. I don't want them to waste a lot of it. And also, if I've had funding to get a certain number of materials, I want it to last as much as possible. So I am quite frugal with a lot of the ingredients because I don't like to waste anything. But at the same time, like if I do know that I'm the only one that's demonstrating something to a whole audience, that I can actually be quite clean and then take it home and eat it all. So I'm quite up for that as well. Like we've done experiments with chickpea tins, and I've just taken it back home and made a whole batch of hummus. So in that way, it's quite good. But yeah, I do tend to not let children waste it too much, and if it does get used and it's all food safe food items, I can bring them back and compost them too, so it all goes back into the whole circle of things, which is great.
So in terms of inclusivity, what does inclusivity mean to you, and how do you make your demos and your science activities inclusive?
So in terms of inclusivity, I was trying to look at how other resource developers, like, I mean, I've looked at some activities where they've expected young people or teachers in schools to go out and buy like quite expensive things or things that people might not want to handle. So, for example, even in the poo scenario, I'll keep going back to poo. Even in there was this whole bit about using crab meat, for example, and there have been other activities that have asked for using beef stock cubes. So just because the resource developer has that in their kitchen doesn't necessarily mean that someone who is a vegetarian or for cultural reasons does not want to eat something. You can't really expect them to have that in their kitchen or to even go out and buy them. Like, I mean, I as a vegetarian would not go out and buy beef stock cubes to then come back just to make something with that and do some science. So I've tried to look at all the items that anyone would have and anyone would be able to use, and also given alternatives for things that if I do think, oh, maybe someone won't want to have milk, what could they use instead? That kind of thing. And then also looking at like glass jars, for example. Everyone has got a glass jar of some sort because there's so many things that come in jars. There's ketchup, mayonnaise, all kinds of like pasta sauces. Everything comes in a glass jar. So being as inclusive in that way, and then stationary items, so paper clips and copper coins and rulers and pencils and, you know, all the bits that you can find in the home or in the school that anyone should be able to get hold of quite easily, was a way to make it as inclusive as possible. All my activities and all the activities that are in the book, all the activities that I sort of do with families and community groups too.
Fantastic. So, what was the first demo you ever designed? Where did you start?
Don't know. What was my first demo? I can't actually remember. I mean, I can remember one of the first activities that I ever did, and that was in that was when I was an undergraduate. So I was part of a scheme that got undergraduates into primary schools to help them with their maths and English. And I was with two really naughty boys that the class teacher obviously didn't want in the classroom, so she just gave them to me. And this was the East End of London. But I felt I had to think on my feet there, and I had to think of ways to engage with them, and they were learning about how to tell the time, and neither of them could get their head around like hours and minutes and how to tell 24 hours and all of this until I started talking to them about what does the clock look like when your favorite program comes on television? What time is home time? And, you know, like actually drawing clocks, and so doing a bit of like artwork as well. They were able to draw clocks and then put the hands and the minute hand and the hour hand, and they were working things out that way. So those kind of activities that come straight to your head while you're actually having to teach things, I quite like, and I think that's the first thing that I really remember feeling. And I think it's because I felt quite satisfied at the end of it that they worked out how to tell the time just based on me saying, "Oh, so when's your favourite cartoon on telly?" So that was quite good. But I can't actually remember when my first demo was or what it was. I might have to think about that a bit longer.
So if someone wants to learn to design demos for kids, where would you say they should begin?
I would say, like there are ways that they could like use what they know and try and work out a way to make a demo. There are a lot of people that do that. They will just start from scratch. But there are plenty of websites out there that have hands-on activities on there. So British Science Association has a whole bunch of science at home activities. There's How to Smile, which is mainly a US-based one. I mean, like just looking for hands-on science activities to do with children, you can find a whole bunch of them online and then just adapt them to whatever it is that you're trying to do. But like I said in my talk, the thing about tonic water glowing and things, so if you know some kind of science, like an indicator science, you can then adapt it to whatever science it is that you're trying to show as a simulation. So there are ways of doing that, but otherwise I think places like the British Interactive Group is a good place to talk to other people that are doing hands-on science demos, engagement, and the whole science show thing, because I mean I was talking about why I don't do science shows because I'm more interested in that small group, sustained engagement. But if people want to know more about science shows, there are loads of people at the British Interactive Group. And they do, a lot of them work in museums, so they know how to work with their local communities. They know how to do these big shows and all the health and safety that comes along with that too. So that's definitely worth a look.
Fantastic. And so is most of your work done kind of in schools, or where do you do these demos?
So a lot of it is in schools, so science clubs. I tend to do a lot of I wouldn't say I do a lot of curriculum work because I quite like that enrichment side of things. So I like the after-school science clubs. I love the science festival events or the community events. So things that aren't necessarily labelled as science. The events that we had like at Ipswich at the waterfront. So it's just people that are walking around and doing their weekend shopping, and they drop by and they come and do a little bit of science with us. And I think that I really enjoy doing things that the children who are interested in science are going to love it anyway, but the children who think they don't like science but then suddenly find out, like for example we made comet cocktails at one point, which was all like it wasn't alcoholic at all for these like 7-year-olds, but the fact that they could make a drink with orange juice and things like that all had elements that were related to the anatomy of a comet, they loved that, and they suddenly saw links between like cookery and what they were eating and how that relates to science. So I quite like doing things like that as well. Whereas it's a little bit more difficult to do that as a workshop within schools, within like the school curriculum. And then otherwise it's working for various clients who I've mentioned in the talk before, and then going out with them and their membership to community events and doing some engagement that way.
Fantastic. Well, thank you so much for your time today. It's been a real pleasure talking to you.
Thank you for having me.
It's a great talk. And for anybody who hasn't already got your book, you want to give us a plug?
They can, yes. So they can get it from Bloomsbury, and it's, yeah, even though it says that it's primary activities, it's actually got quite a lot of hardcore science in there that would be great for like any parents and teachers who want to get to grips with the science to then explain to their young people, but also for all those young people that want to know more, as well as like Key Stage 3 students as well might find it really interesting too. So yeah, Bloomsbury, woo!
Lovely. Thank you so much.
Oh, thank you.